Hi class, Mrs. Calvi here. Quick review on rotating figures in the coordinate plane. This is the last of the transformations that we're going to be talking about, and it is by far the most difficult. But if you really pay attention to what I do, it's not that hard, believe it or not. All right, so what I'm going to do is I have an example here. It says rotate rectangle PQRS 90 degrees clockwise about the origin. So about the origin means 0.00, right? So we know the origin is 0, 0. So we're rotating it around that point. It just so happens it's rotating around the origin because that point lands on the origin, point P, if you notice there. The other important part is we have to look at how many degrees it's rotating and in which direction. So clockwise, that's the direction the hands on the clock move. So clockwise would be going in this direction. Now 90 degrees. So 90 degrees is equal to 1 turn. If it said to rotate it 180 degrees, that would be 2 turns. And if it said rotated 270 degrees, that would be 3 turns. And I'm going to explain what this means in just a second. Okay? So, again, the blue figure is my original figure, and they want us to rotate it 90 degrees clockwise. So 90 degrees is 1 turn going in the direction of the hands on the clock. So they already rotated it 90 degrees, and the new figure is the red rectangle here, okay? We know that because it has the prime marks. So it went from being in quadrant 1, right? Quadrant 1, rotating it 90 degrees clockwise, it landed in quadrant 4. Okay, so I'm going to show you what you would do. Now, if we were in class, we would use graphing paper and we would create a coordinate plane, and I would actually have you rotate your paper because it is the easiest way to do a rotation. Now, the one tricky part is the minute we rotate this coordinate plane, you can no longer look at the positive and negative signs on the number line because they're going to change as we rotate, and I'm going to show you what that means. So I'm going to rotate this coordinate plane. Now remember, they rotated it here, and the red figure is where it lands in quadrant 4. So watch as I rotate this. I'm going to go 90 degrees clockwise. And if you're using Clucky at home, you can do this also. If you go to the Edit tab over here, they have a Rotate tab. And it says to rotate either counterclockwise, which is going left, or clockwise, which is going right. They're telling us 90 degrees clockwise. So I'm going to click this once, and I'm going to click OK. So if you noticed, look, our original figure landed in quadrant 4, exactly where that red figure landed. So it's easier to physically rotate a piece of paper to find out where the figure ends up landing. Now, the tricky part is when we go to identify these coordinates, remember I said you can no longer look at the sign, the positive and negative signs on the number line, because you have to think of this as being our new direction of our coordinate plane. So let me just rotate it back. Okay, so now to identify the coordinates of the new figure, you would identify this as, let's see, 0, P, that's a P, right? So P prime is 0, 0. S prime is 3, 0, right? So to the right, 3, staying at 0. Q prime, we're staying at 0 and going down to -4. So 0, -4 is going to be our P prime, right? Or our Q prime, sorry, 0, -4. And then our R prime, starting at our origin, we are going to go right to +3, down to -4. So R prime is +3, -4. So when I rotate this physically, you have to remember that the signs are going to change sometimes, All right. And I'm going to show you that in a different example to make you to make it a little bit more clear so you can understand. So let's get another example. Okay, so this is where you're going to see it a little bit more clear what I'm talking about, how once you rotate the actual coordinate plane, you can no longer look at the positive and negative signs. You just have to always remember that left is negative, right is positive, up is positive, down is negative. So I have this figure here, A, B, C, D, E, and I want to rotate it 90 degrees counterclockwise. So 90 degrees is one turn, counterclockwise is going left. So I'm going to rotate it 90 degrees counterclockwise to see where it lands. Right now it's in quadrant 3. Let's see where it lands when we rotate it. So we are going to rotate it 90 degrees counterclockwise. Okay, so if you notice, it now landed in quadrant 4. You can't look at my my writing here anymore, because now that the coordinate plane rotated, everything changes. So you have to remember that to the right, these numbers are always positive. Down, these are negative. To the left, they are negative, and up, they are positive. But if you notice, when I rotated this, what are we seeing? We're seeing that, that's interesting. These are positive, but because the coordinate plane rotated. So that's the hardest part for students to remember. Once you rotate your coordinate plane, you can no longer look at the signs that are on the coordinate plane. You just have to remember, to the left of the origin, they are negative. To the right, they are positive. Down, they are negative. Up, they are positive. So knowing that these land in quadrant 4, you should know, I kind of have it here, right? Quadrant 4 is going to be, you can't look at this actually, because that's from when it was in quadrant 3. These are going to be positive, negative. So all of these points are going to be positive, negative, because they land in quadrant 4. Positive, negative. So now when we go to list our coordinates, A prime, so A prime, starting at my origin, I am going right to, let me see if I can increase to see it a little better. I am going right to positive 7, and I'm going down to negative 4. So 1, 2, 3, 4, 5, 6, 7, positive 7, 1, 2, 3, negative 4. So positive 7, negative 4 is my A prime. So my B prime, starting at my origin again. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And then I'm going down, negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, negative 8, negative 9. So positive 11, negative 9. So remember, they have to be positive and negative. So far, so good. My x's are positive, my y's are negative. Okay? All right. So now we would continue C prime. We would go right to positive 9, down to negative 11. Positive 9, negative 11. And then you would continue on. Okay? So let's say we were to rotate this differently. Let's see what would happen. Okay, so let's look at a different one here. Okay, so same image, but before I rotated it 90 degrees counterclockwise, and it landed in quadrant 4. Now we are going to rotate it 180 degrees clockwise. So 180 degrees is 2 turns. Clockwise is going to the right. So let's go ahead and rotate that. So 2 turns, right? So clockwise here, 2 turns is going to be 90 degrees twice. So 1, 2. Now let's see where it landed. It was originally in quadrant 3. It's now in quadrant 1. Now all you have to do is identify the coordinates of each of these new points. And remember, they become prime. A prime, B prime, C prime, D prime, and E prime. Again, you have to remember, you need to ignore the signs that are here. So you know if it's in quadrant 1, remember, you can't look at this anymore. So you can no longer, you can't look at this and you can't look at this. This is now quadrant 1, because if you look at a coordinate plane, the top right is your quadrant 1. And these, if you go right, they're positive, up, they're positive. So these should all be positive, positive, the ordered pairs or the coordinates. So let's see what happens when we do that. If we identify A prime, let me try to just zoom in a little bit. A prime, right? So we are going to, remember, these are not negative, these are positive going to the right. Positive 1, positive 2, positive 3, going up is positive. Positive 1, positive 2, positive 3, positive 4, positive, oh, I was supposed to go over to 4. Sorry, guys, let me start over. Positive 1, positive 2, positive 3, positive 4, positive 1, positive 2, positive 3, positive 4, positive 5, positive 6, positive 7. So A prime is positive 4, positive 7. So remember, it should be positive, positive. So far, so good. So if we ended up having a negative here, that's a red flag, because if they land in quadrant 1, they should both be positive. So again, rotating is not so bad if you physically rotate. The hardest part is just remembering when you identify the coordinates of the new figure, you have to ignore the positives and negatives on the number line and just remember whatever quadrant it's landing in, remember whether they are supposed to be positive, 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 negative, and so on. Okay, so not so bad if you actually physically rotate the paper. All right, that is it for rotations, and I will talk to you guys